Welcome back to a new episode of Passion for Technology, the podcast from EPD Electronic. Great to have you with us.
Welcome to the Passion for Technology podcast. Electric motors are the quiet workhorses of modern industry. Globally, there are an estimated 700 million electric motors in operation, with around 300 million powering the industrial sector alone. And that number is only set to grow as electrification continues to expand across every sector, driving advances in industrial automation and the adoption of electric vehicles. But here's the catch. Electric motors account for about 65% of industrial electricity consumption. That makes their energy efficiency not just a technical priority, but a critical factor in the global energy landscape. In this episode, we'll dive into how the latest innovations in drives and semiconductors are shaping the future of more efficient electric motors, and why it matters for businesses, grids, and sustainability. To find out how electronics can help and what the trends in the motor control market look like, we invited two returning guests to chat with us today. One of them is Milan Ivkovic, and Milan is the director of the Analog and Power segment at EBV. Hi, Milan.
Hi, Mustafa.
And the other returning guest is Canberk Cesar, who, as I just learned, moved from Istanbul to beautiful Munich. Canberk, you're the software field application engineer for digital motor control at EBV. Hi, Canberk.
Hi, Mustafa. Thank you.
Milan, what are the drivers for the growth of the motor control market? Where are the most important application areas today?
Well, first, very important in this moment that we have different forecasts of recovery and growth in industrial and automotive markets, and especially in automotive in electrified powertrain and industrial electrified transportation and automation. We see projection of double-digit growth year over year. We see also that there is like a boom of smart robots. And for sure, there is a need for green energy and heat pumps as a technology for heating. So all of these applications have kind of motor drive inside. And actually, these applications are something that is driving the whole market forward and motivate the development of new technologies.
Thank you, Milan. So that's the application space. Canberk, maybe you can help me understand the big technology trends that are currently shaping motor drives themselves. Where's the development heading in the next few years?
Actually, it will be best to answer this question from two different perspectives. We can say digital and power. First, let's talk about digitalization and smart control. Motor drives are no longer just devices that transfer power, but systems that can perform smart analysis. With advanced algorithms such as FOC, means field-oriented control, the performance of motors can be optimized more precisely. Additionally, artificial intelligence and machine learning are making their impact visible in motor drives. For example, AI-based systems reduce maintenance costs by reducing the use of sensors and allow us to predict failures in advance. Moreover, with edge computing, analysis can now be performed on the drive in real time. This improves system performance and speeds up data processing. And another big technology trend is the rise of wide bandgap switching devices. The silicon carbide and gallium nitride technologies I mentioned in power, these devices provide much higher efficiency and performance compared to traditional silicon-based switches. Higher switching frequencies make smaller and lighter designs possible. This is particularly advantageous in consumer electronics and industrial automation applications, where the demand for energy savings and compact systems is increasing. As a result, motor driving technology is rapidly becoming digitalized and smarter. In addition, wide bandgap devices are becoming increasingly important as solutions focused on energy efficiency and sustainability develop. In the future, the combination of these two main trends will lead to smarter, more efficient, and greener motor drive systems.
Milan, Canberk now mentioned wide bandgap and gallium nitride or SiC. One major area of application is power electronics for drives. Maybe you can elaborate a little more on how those materials are impacting the market?
Well, first of all, when we say wide band gap, it is material itself, but we have to say that trend is improvement of all semiconductors materials, integration of several technologies into single package, and advance of the packaging itself, because this is also needed to support new technologies. So definitely we see commercialization of silicon carbide and gallium nitride, and this is really big trend and it has major impact. But also we see slight improvements in existing silicon technologies for IGBTs and MOSFETs, which are still competing on the cost level. And then we have a trend of integration. So we see different integration of drivers and switches. We see current sensing integrated into power switch and common topologies needed for motor drives that are integrated into a single package. This is a really easing design process of the drive and making everything faster in terms of time to market. And also very important is packaging, because new materials, they require better packages with lower inductance, higher power density. And this is something that is also bringing new concept of coolings and concept of the design partition when it comes to motor drives.
Thank you. Thank you for providing that level of insight and the broad scope. You know, if I recall correctly, when we started Passion for Technology many years ago now, we started with wide bandgap materials, and we started with episodes on silicon carbide and gallium nitride. Milan, can you briefly explain the difference between silicon carbide and gallium nitride for us? What are the respective advantages and areas of application?
Yeah, this is good to see a lot of improvement in the last few years since we started these discussions. So today we have, I would say, also clear differentiation between these two. So both materials are with high bandgap voltage and they have high critical field. And these two are essential for low RDS on and high breaking voltage. Then it means we can build power switch with these two. But they have different crystal structures inside. So this leads to different device structure of the power switch. So silicon carbide is a MOSFET structure, while gallium nitride is a high electromobility transistor. GaN, with its properties, can run at higher switching frequencies. So it means with the impact of the passes, it is possible with GaN to make highest energy density where needed. So naturally, these applications will be like data centers, some power supplies, either commercial chargers, then some solar converters, onboard chargers, and very important, traction drives. There are investigations in this direction. There are also on the market implementations in the motor drives with GaN, because the very high energy density can bring to integration of the motor drive and the motor itself. On the other hand, silicon carbide has higher thermal conductivity. And this is very important that for very high power applications, it can, let's say, remove heating from the material itself. So silicon carbide is switch of choice for high voltage applications and high power applications like industrial power supplies, DC chargers, big traction drives, and so on. And one very important thing here is benefit of GaN, that GaN in general is cheaper to produce than silicon carbide. So GaN is good candidate to replace silicon MOSFETs, not just on the performance, but also on the price level.
Janberg, Milan already touched on how gallium nitride power electronics, how they impact drive technology. Can you elaborate a little more on the advantages that come with gallium nitride for power electronics for drive technology?
Yes, absolutely. GaN is an innovative technology that is reshaping motor drive designs. The most attractive feature of GaN transistors is that they have much lower conducting and switching losses compared to conventional silicon-based devices. This dramatically improves the overall energy efficiency of motor drives. Less energy loss means less heat generation. As a result, the need for large and costly cooling system is reduced. In other words, GaN not only makes system more efficient, but also reduce design costs. In addition, the high switching frequency offered by GaN technology allow the use of smaller passive components. This reduces the size of components, especially coils and capacitors. The result is more compact and lightweight motor drive systems. This is a great advantage in both consumer electronics and industrial applications. Also, when we want to design more performance-enhanced motor control systems, GaN's fast switching characteristic and low parasitic capacitance make it an excellent choice for high-speed motor applications. This makes a big difference in areas such as robotics, drones, and industrial automation, where precision control is required. Overall, GaN technology offers remarkable advantages in terms of energy efficiency, compact designs, and high-speed motor control. This makes it the technology of the future in motor drive designs.
And what would you say how that impacts development engineers? What influence do GaN semiconductors have on, let's say, the control of inverters, for example?
Yeah, I would like to talk about the digital control sides coming from my experience. As mentioned in previous questions, GaN is a fast product compared to silicon MOSFETs. The high switching frequencies provided by GaN semiconductors significantly increase the speed of control loops. This means that critical parameters such as torque and current control in the motor drive can be adjusted more quickly. With this speed boost, development engineers can design much more dynamic and responsive motor control systems. Of course, this type of acceleration needs to be tested in the system, and the design needs to go outside of the conventional solutions and use structures that can keep up with this fast operation. Along with this speed, GaN technology also offers us wider bandwidth for the control. This enables higher precision in torque and current control. For example, the response time to fast load chains in the system is significantly reduced. For development engineers, this means delivering superior performance even in more complex and demanding applications. By reducing the load change latency in the control design, they can make sure that the system keeps its stability. Another impact of using GaN for designers is on the digital control side. There needs to be an acceleration in the timer structure used in microcontrollers. Of course, in order for this acceleration to be controllable, core performance is another detail to be considered in this regard. For this reason, analog structures in the microcontroller, such as comparator, DAC means digital analog converter, or PGA, programmable gate arrays, etc., can be included in the design so that some of the signal operations can be performed independently of the core. Microcontroller manufacturers are also considering these needs and are producing new products with this perspective. In order to maximize the advantages of GaN, designers should pay attention to such important points when choosing a microcontroller and designing digital control systems. Maybe Willem wants to share his comments for the power side.
Yeah, sure. So sometimes people say GaN is close to ideal switch. So in ideal switch, we have indefinite rates of change of voltages and currents, right? And in non-ideal environment, this is a disaster. So good thing is not 100% true, but definitely GaN comparing to silicon has very sharp or very high rates of change of voltage and currents over the time. So layout of the power loops as a source of different emissions has to be minimized. And also gate control loop has to be optimized in order to have really proper switching of the GaN. So not going according to directions, rules, and so on can really cause malfunctioning of inverter itself. GaN is a bit different for driving comparing to MOSFET. So this is where attention has to be paid. Although there are different types of GaN, which would be too wide topic for today, in some cases, this is not an issue. For GaN, also in some implementations of GaN, In reverse conducting, it can have a very high voltage drop. So synchronous switching is mandatory. And of course, for motor drives, short circuit current and capability is very important. So this is what designer has to pay attention. And then GAN is enabling us to create bidirectional switch. So bidirectional switch is actually something that can introduce new technologies into inverter like current inverters, which was not commercially viable today.
Across which voltage ranges are GAN components predominantly used?
Today, GAN is very stable into low voltage classes up to 100 volts. 100 volt and 150 volt, we can call it medium voltage GAN. There are a lot of devices on the market. And for the higher voltage level, we have between 600 and 750 volt voltage devices. So this is where GAN is targeting silicon MOSFETs and IGBT applications. In the future, we can expect commercial devices as there are a lot of developments into 1200 volt range, which would be reserved for cascode D-mode GAN. But let's see, this is something that will come in the future. Hopefully, we'll have some podcasts on this as well.
Jan-Berg, how does EBV assist developers in designing effective drive electronics?
As we have just mentioned, there are many details to consider when designing a motor driver with GAN. Moreover, in such a complex process as motor drive designs using traditional or next generation switches like as GAN, it is very important to have expert support at many points, from selecting the right components to circuit design review. One of the most critical steps when designing a motor drive system is choosing the right components. We, as an EBV, offer a broad product portfolio to support developers in selecting components that best suit their needs. We provide expertise in selecting the right products for innovative solutions, such as power electronics, control circuits, and wide bandgap semiconductor selection, which are particularly important in motor drive design. And additionally, EBV offers schematic and PCB review services to ensure that your designs are both functional and manufacturable. This service is invaluable for identifying unrecognized errors during the design process and receiving suggestions for improvement. This gives you an additional perspective during the development process. And we have talked about product selection and production, but EBV also provides regular technical support for the development process. Technical problems encountered during motor drive development can delay the project. EBV provides technical support at this point, helping you solve problems quickly. This applies to both hardware and software challenges. You can see us as part of your design team and ask questions on all technical issues. Last but not least, EBV's workshops, webinars, and training sessions offer a great opportunity for developers who want to learn about motor drive technologies. And these activities allow you to increase your theoretical knowledge, stay up to date with developments in the market, and learn solutions for practical applications. In short, you can contact us about these products and discuss all technical details for your project with us.
Besides wide bandgap power electronics, what other notable trends are you observing in your technology segment, Milan?
So, and mentioned earlier, wide bandgap is still on the price level not comparable with the silicon technologies. So there is a lot of investment to improve current silicon technologies in order to have a smooth continuation and competitive devices from producers in this area. So IGBTs are improving, lower saturation voltages, lower switching losses, medium voltage MOSFETs, especially in like 80, 100, 120, up to 200 volts are developing, because this is area where we see a lot of applications now running from 48 or 96 volt battery, talking about motor drives for sure. And then finally, packaging. Trend is really to move away from traditional TO packages like 220 or 247 and traditional SND deep pack and D-square pack towards more performance lower inductance, better thermal conductivity SNDs in very small 3x3 up to like 10x12 packages, even with options like topside cooling, which is now completely changing the way how heat is removed from the board.
How do you both view the future prospects of the motor drive market? I mean, Milan, Janberg, feel free to start and then the respective other to just add to it. But I'd be really interested in, what your perspective is on the future of the motor drive market.
I can start maybe, as mentioned at the beginning, there are a lot of new motor drive applications, and with their requirements, technology has to enable actually what is needed by the application. And some of the key factors for sure will be energy density. This is where wide bandgap is playing the key role. Gallium nitride maybe even more. Packages, as I mentioned, and also integration, because at the end it makes designs more compact. Then there is a price, and here this is good future for the GaN. And for sure there is a component availability as a factor, because some manufacturers will need multi-sourcing of components for their designs. But if not, for sure, a number of different suppliers that is providing devices in certain technologies, somehow raising the probability that this technology will be on the market available in the following years. So Jamer, maybe you can add.
Yeah, I can share my ideas with the general perspective the first time. For the future of the motor drive market is very positive, I think. With technological innovations, exciting developments are taking place in this field, and cost-effective solutions will become more dominant in the motor drive market in the future. Sensorless high-precision control methods reduce the complexity of the systems, while at the same time improving performance. This approach will be especially in demand in consumer electronics and low-cost industrial applications. Secondly, as I said, AI technologies are enabling the concept of predictive maintenance in motor drives. Systems can provide warnings before failures occur, reducing maintenance cost and increasing operational continuity. And predictive maintenance features are rapidly becoming standard in industrial automation and IoT-based solutions. Among the biggest advances are the effect that GaN, which we have discussed in detail today, has provided and will continue to provide. The advantage of wide bandgap semiconductor as a GaN enable motor drives to respond more dynamically and quickly at big loads, especially in braking and torque inertia management. GaN solutions take system performance to the next level. This creates groundbreaking change in applications that require high performance at big loads, mechanical loads. Overall, the future motor drive market will be characterized by more precise control methods, AI-based predictive maintenance features, and systems that offer ultimate performance at high loads. These innovations will lead to more efficient and sustainable solutions across the industry.
EBV will be exhibiting at Embedded World 2025 in Nuremberg this March, and if I'm informed correctly, also at PCIM Europe in Nuremberg in May. What can visitors look forward to from EBV Electronic at these events, Milan?
You're right. We will be at the exhibition at Embedded World and as well at PCIM in May in Nuremberg. So regarding motor control, we will show some solutions like new controllers with GaN devices. We will also show some 6-phase fault-tolerant solutions. But besides that, for sure, there will be a lot of interesting topics and new products in power semiconductors, GaN, silicon carbide, IGBTs, and power controllers for sure. So I invite you to visit our booth at Embedded World and PCM this year.
That sounds awesome. Well, you know what? We've actually reached the end of our podcast. And as you know, both of you are returning guests. At the end of our podcast, in every single episode, I love to learn more about the origins for your passion for technology. So, Janberg, why don't we start with you and give you yet another opportunity to introduce our listeners to where your passion for technology originated from?
I can answer this question by referring to what we talk about today. We talk about innovations and developments. I am someone who regularly feels my passion for technology in real life because my passion comes from always being at the center of innovations and developments, being able to experience them quickly. In this way, I feel like I can keep up with the developing world and feel like I can shape it. That's it from my side.
And Milan, you've been on the show. First of all, thank you, Canberk. And Milan, you've been on the show quite a few times. Now, you will need to dig deeper and share, more juicy bits and pieces from your, early childhood, teenage years, wherever the additional origins of your passion for technology lie.
No, I've been several times talking about this, so I have to be consistent as well. But sure, my origin and motivation is really first challenge is problem solving. And this is coming from when I was a child, I think. And then it was just reflecting while I was learning maths, physics, electronics, and so on. And this is like an excitement of solving something by the help, right, of the technology. And then these days, I can say this is coming as a boomerang because doing something in our lab in EBV, and then there are different technologies available. And then it is just making a lot of challenges what to use. So it's like we are with a lot of choices, a lot of possibilities. There are big challenges ahead us. But I think that actually different options, different opportunities is motivation to find at the end solution that is optimal. And then this is definitely by the help of technology. So something that you do today, for sure you couldn't do like 10 years ago. And this is at the end exciting when you see.
I agree. Absolutely. I'm probably less of an electronics person than either of you are, but more of a computer science person. But you know what? Over the Christmas holidays, I started fiddling with Raspberry Pi projects and MicroPython on those. And you're right. The passion and the excitement never stops. Electronics is incredibly exciting. And the things you can do with, programmable electronics is just extremely, extremely interesting. Well, thank you, Milan, and thank you, Canberk, for the insights that you've shared with us today. And dear listeners, as always, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the many other popular podcasting platforms. Milan, Canberk, thank you for joining us today.
Thank you, Mustafa. Thanks for everybody.
Thank you, Mustafa. Also, thank you, Milan.